everybody, very good morning all and very warm welcome to the session. So happy and really excited to meet you all back in this awesome session. Yes everyone, so today we are going to see about Unit 5. Yes Shiva, very good morning, have a great Sunday. Yes Bikram, Amrita, Himanshi, Gaurav. Yes everybody, so I hope that it is all clear. I am streaming live, I guess. Any issues in this thing? So far I was not able to connect. I think now I am available. Am I right guys? Yes or no? You all can see me? Okay. Yes everybody, very good morning all. So happy to meet you all back as I said. Okay. Fine guys. So let's start up the session. Yes, Anthony, Himanshi. Okay, fantastic. Yes, Shipra, Mithila. Yes, Gaurav. Very good morning, everybody. So happy and fantastic to meet you all in this session. So today we are going to do a rapid revision based on your MCQs as well, such that you can make a lot of points from this Unit 5. So there's a small few announcement from us at Unacademy. The notes for your CSIR NET is going to be available soon. So definitely it will be a great help for you all. This is little bit about me. If at all you're watching me for the first time after Dr. Saranya, I have completed my Ph.D. in Biomaterials. Okay, so and I have already cracked NET and I'm teaching for a long time now in my career for aspiring all your CSIR NET aspirants. Right. Fantastic. I have 15 papers to my credit. You can search me in the Google Scholar as well. Okay, fine. Yes, connect me through LinkedIn, Unacademy app, anything as you please, such that you can take it forward. Okay, so this is the difference between the Iconic as well as the Plus subscription. Absolutely Iconic has few advantages over the common Plus subscription because you will get end-to-end guidance. So this is the benefit that you get out of this Iconic as well as the Plus subscription. Keep well informed about all those things. Yes, if at all you're watching for the first time. Yes, Rumi, Yogamper, very nice everybody. Okay, fantastic guys. So currently an offer is going on. It is a 49% offer. This offer is extended till July 31st. That is today. Okay, so you'll be getting this offer by till today. Okay, so use it and get the maximum out of it. Okay guys. So what is the first important topic in developmental biology? It is about induction, competence. Yes. So induction, competence, and then interaction. All these are the key words. Definitely, if at all you are able to answer this question and also the terms that is given in this question, every aspect you are going to revise from this single question. So many key words are there. So let us see. And this is coming under Unit 5A. Okay, right. Fine. Yes, Meta. Yes, Mithila, Sayanti, Himanshi, Shipra. So the cell-to-cell communication is important. So the ability of the cells to respond to a signal. So a cell is responding to a signal. So what this ability it is called as? Yes, everybody. Yes, Gaurav, Rumi, Shipra, Himanshi, Shayantini, Mithila. Fantastic guys. It is going to be the competence. What example you remember for this regional specificity of induction? For regional specificity of induction, what example do you remember? Regional specificity. So something you remember with reference to this mesenchyme and epithelial interaction? Mesenchyme and epithelial interaction. Yes, Tanmoy, correct. B is the answer. Yes, Rumi. Yes, Nupur, correct. So if you put this wing will come, isn't it? So if you put this wing mesenchyme, wings will come. So if it is going to be your thigh, okay, so thigh feather will come. If it is going to be this end, then it is going to be a claw. Okay, you remember that. So that is what is the regional specificity of induction. So this mesenchyme is only going to dictate. One more position, this was reproved. Do you remember with these limbs? Under the limb development also, we could have studied the same concept. If I put under this AER, so this AER, it is not at all going to specify the limb. AER will help, okay, but who will specify The specification is only going to be by the limbal mesenchymal cells, isn't it? So if at all I am going to put my forelimb, what will develop? Forelimb mesenchyme I am putting. Okay. So if I put my forelimb mesenchyme under the hind limb AER, what will develop? What will develop? Will it develop into a wing or a leg? So it is going to develop into a wing or a leg. Between, tell me what? Yeah, it is going to develop into a forelimb. So that is my next question. So forelimb, okay. So forelimb, it is going to form leg or wing. Normally, forelimb means it is representing the leg or the wing. Think and answer, everybody in this class. Take your time, not at all an issue, but please study whatever you are studying in depth such that you will not have any confusion. Yes? Okay, so if at all I have a forelimb, what is that? Forelimb means it is going to be the leg or it is going to be the wing. Fantastic. So many are very clear. Yes? Absolutely. Come on guys. Make it out, make it out. Yes? Okay. Fantastic guys. Right. So we have also studied the genes. TBX 4 and 5. Yes. So we have studied the genes TBX 4, TBX 5. So for your this thing, for your forelimb, it is going to be TBX 5. For your hind limb, it is going to be TBX 4. So these small things also you have to remember. Got the logic? Yes, everybody? So let it be a very small thing. Absolutely. Oh, Sandhya, thanks a lot. Yes, Sayantani, I didn't see your comment so far. Yes, Mithila, Sayantani, Nirmala, Himanshi, Gaurav, Sayanti, Tanmoy, Mithila. Nice, everybody. So all these facts you have to remember. So that is the concept of yes, Sandhya. Maybe it should be no, they didn't call, close the application yet. So after the closing, they will take definitely a month time. Okay, so you can expect in the mid or maybe in the end also, it is probable. Okay, because the application is not at close, no. So after closing, they may call for correction. After correction, they have to look for the hall tickets, admit card, and all the process are left. Yes, so maybe you can expect in this mid of September or end. I probably expect it in the end. Let us see. Okay, so next is justacrine signaling. What is the difference between paracrine and justacrine? Justacrine means any molecules it is involved? No molecules, isn't it? If at all it is going to be the paracrine, then only molecules will be involved. Okay, if it is going to be the justacrine, no molecule is involved. In justacrine, it is going to be no molecule. Okay, right? Yes. So if it is going to be the justacrine, no molecule is going to be involved. If it is going to be a paracrine, okay, so if it is going to be the paracrine, no, that is only going to make up. Okay, right? Yes. So that is only going to make up. Got it? So it is clear. Okay. So between we left this question in between and went for some other topic. So forelimb means I was asking you it is going to be the wings or the leg. Remember that. Yes, Amrita. So forelimb means it is going to be the wing. Leg is going to be your hind limb. Yes? Yeah. So, and yeah, absolutely. So, hind limb is going to be this leg and this forelimb is going to be the wings. Absolutely. So, that confusion is also over. Yes? Okay. So, 4 means, yeah, absolutely. So, the forelimbs, it is what is modified into the wing. Okay. Right. Yes. And then this hind limbs, it is only going to be the, this thing. Okay, fine guys. So coming back here, coming to instructive interaction. What is this instructive interaction? Okay, so instructive interaction means, yeah, so we have seen two things. One, it is going to be the permissive. Permissive means it is going to have only the, so what do you mean by permissive interaction? For example, I have a stem cell. Okay, so stem cell, it has all the factors within. Yeah, so they need only this environment or the nick to develop. Okay, so this is what is called as your, so what is already there. But if it is going to be your cell line, think everybody. So all these are reclincing your mind. If it is a cell line, it is already determined. Okay, right, fine. So it is only going to divide. Okay, so what it is going to make out, all these points you should definitely rethink such that you will be getting off with the good things. Okay, so if it is going to be a permissive interaction, right, so it is already it is determined, so it is dividing, so this is what is going to be the permissive. Okay, but as far as the stem cell, all the factors are there, no, so it is going to be your instructive. Okay, instructive. Am I clear? The signal is not there. Okay, instructive interaction. So what do you mean by instructive interaction? Instructive interaction means it is going to give the instruction from within. So which is going to give this instructive interaction? It is going to be your stem cells, right? So stem cells, they only give this instructive interactions. Okay, so got the difference between these two. What is going to be the permissive interaction? Yeah, absolutely, as well as this instructive interaction. Yes, so this is what it is going to be, the interactions. So now all the terms are thorough to you. Okay, so what is my optic vesicle? That is the next question as well. Okay, so let us take one more key point on this. Okay, so what is going to be the optic vesicle? It is an inducer or a competent factor, competent cell. It is an inducer or it is a competent cell. Yes, everybody. Clear or not? It is an inducer. This optic vesicle, it is only going to, yes, Nupur, Shayanti, Shipra, Moon, Rumi, it is only going to induce your lens. So it is called as inducer. Okay, right. And what is this competent cell? It is the head ectoderm. Head ectoderm alone is called as the head ectoderm alone is what is called as the competent cell. Okay, so PAC6, it is present in inducer, in the competent cell like head ectoderm. It is present in non-competent cell like trunk ectoderm. None of the above. PAC6, where it is present? Come on, everybody in this class, answer this question. PAC6, where it is present? Be quick. Fantastic, guys. So PAC6 must be present in the competent cell like your head ectoderm. Absolutely, PAC6 is present in the head ectoderm. Okay, so PAC6 alone is enough. PAC6 alone it is enough. Think and let me know. Do you think that PAC6 alone it is enough for your lens development? No, you are going to require BMP4, FGF8, right? So many factors are there. Okay, IMAF, LMAF1, like that. Several factors and interactive molecules. It is all necessary. OCT, SOX. Okay, so like that, Several factors are there. We cannot say that PAC6 is exclusive. We can never say that. Okay. So one more question. Let us see. This is regarding this instructive and the permissive interactions. So there are two major modes of this inductive interaction during development. So the following one is comparing the cell lines with the cord blood stem cells. Yes, just now we saw the concept. The cell lines which are stored, it can be retrieved. Okay, so this cord one, it can be retrieved for procuring the stem cells. Okay, the stem cells, it is induced to undergo further differentiation to the desired lineage. So which of the behavior is correct? Both cell lines and stem cells, they show instructive interactions. Cell lines, they show instructive interaction, whereas the stem cells, they show the permissive interaction, or cell lines, they show the permissive interaction, where stem cells show the instructive interaction. Both of them are permissive. Which of the following is going to be correct regarding your stem cells and the cell line? Is it a permissive or it is going to be an instructive interaction? Fantastic, guys. Yes, everybody. So the cell lines, it is permissive, but in stem cells it has all the instruction within. Yes, Chipra. Yes, but Mithila, Himanshi, Nupur, Moon, Sayanti, Gaurav. Fantastic. Yes, everybody in this class, you are 100% right. So C is going to be the correct answer for this question. Clear all? So now you understood small definitions only make up a very big concept. Okay. So one more question from this interaction. Let us see. The lens formation. Okay. It is going to require sequential events. Okay. Right. But if you take this anterior neural plate signals, the anterior ectoderm, it is going to promote the secretion of PAC6, which renders the anterior ectoderm more receptive to the secretions from the optic vesicle. So the above can be best explained by which of the following phenomenon? It is an instructive interaction, epithelial mesenchymal interaction, permissive interaction, induction and competence. Yes, Sayanti, Mithila. See, the concept of your developmental biology is that if you read everything, all the term you will be knowing, right? Yes. So you know now what is instructive interaction. You know now what is permissive. You know what is an epithelial mesenchymal interaction. You know what is induction and competence. So now easily you can come up with the answer. Yes, Moon, Himanshi, Chipra, Nupur, Gaurav, but very good everybody, no doubt this is going to come only under the induction and competence. So D is going to be exactly the correct answer. Now this concept is clear to you. So what are the keywords we have noted now? We have learned what is an induction and we have learned what is going to be the competence. We have learned what is the regional specificity. See, these are the keywords. Okay, so always whenever you are preparing for the examination, so not only you have to look at the MCQ, but the options. Okay, this option is only going to serve as a keyword for the next question. Okay, so this exam is over, but the upcoming examination using that keyword, they may ask with the next question. So instructive interaction, permissive interaction, regional specificity of induction, competence, induction, all these things are clear. Okay, what is this genetic specificity of induction? What example do you remember from this genetic specificity of induction? Do you remember this concept? Genetic specificity of induction. What is the example that clicks your mind regarding the genetic specificity of induction? Induction is of a different type, isn't it? Yes. So we have studied this lateral induction. Like that, it is going to be the genetic specificity of induction. Come on guys, think and let me know. Yes. Yes, everybody. Which good example you remember? So you remember about this Newt example? Newt? So see, you remember this model from this frog gastrula. Okay, so what they will be doing? They will be transplanting, okay, this ectoderm, okay, right, to the newt, okay, right. So actually this is going to be a newt, but this newt will be having tadpole sucker. Why? Because this part has come from this frog. Okay, so that is why it will look like that. Likewise, they did one more experiment. From the newt, they transplanted this ectoderm to the frog. Okay, so now what will develop? A frog with balancer. Why? This is specific for the newt. This is specific for the frog. That is why it is like that. So it is all the genetic specificity of induction. Got the logic, everybody in this class? Now you understand? Absolutely. Yes, Nupur, Moon, Sayanti, Sumit. Yes, but. So this is what is called as the genetic specificity of induction. So now you remember, you remember genetic specificity of induction, regional specificity of induction, permissive interaction, instructive interaction, induction and competence. Okay, so only one term is left over from 5A. What is that? It is going to be the specification. Okay, under the specification, you have three types. One, it is going to be this autonomous specification. Another one, it is going to be the conditional specification. Another one, it is going to be the superficial specification. Superficial is noted only in the insects like Drosophila. Autonomous means it is carrying on its own. It is called as mosaic or it is called as regulative. Right. Conditional, it is going to be dependent on this environmental. Okay, so it is called as regulative. Okay, so it can regrow things. So this is dependent only on the factors that is present. Okay, fine. So one more example from the specificity we will do before we go off. In chick, the development of wing feather, thigh feather and claws, it depends upon the epithelial specificity. So you have to connect all the questions. So if you connect all the questions of what is being asked and what will be asked, definitely you can spot a plan on this. Did you get an idea now? Okay, so in chick, the development of this wing feather, thigh feather and this claw, it is depending on this epithelial specificity. Okay, so what kind of example is this? It is an autocrine interaction, it is a regional specificity of induction, it is a receptor activation or it is an inactivation of genetic interaction. Very direct, no? Yes? So this is absolutely yes, Mithila, Nupur, Shayanti, Moon, yes, but Gaurav, correct everybody. So this is none other than regional specificity of induction. One more time, what is the example for genetic specificity? We saw about this frog versus newt model. Okay, because this is already asked, they may ask this one. So like that you should be ready. Yes, Himanshi, Shipra, got it everybody? Yeah, so regional specificity of induction, example, it is going to be your thigh, wing and claw. But genetic specificity of induction, it is going to be this frog and the newt. This is how they will set the questions depending on the blueprint. Okay, so the next thing we have to move, it is like your morphogen. Okay, so morphogen, it is cytoplasm based, or what basis this morphogen will come? It is based on maternal or paternal? Morphogens. They are cytoplasmic maternal molecules, isn't it? Okay, so which one of the following? It is a group of molecules, yes everybody, that act as a morphogen during the development of the organism. So that is okay, right? Fine. So development of organism, everybody is there. But they have given one more word. Yeah. So this receptor, it is going to be smoothened. Okay, so who is the receptor? The receptor, it is going to be smoothened. Patched. Okay, patched. and then it is going to have this smooth end as a binding partner. Yeah, so patched means it is hedgehog. What about notch? Notch is delta. Vint is frizzled. Vint is frizzled. Beta catenin. DSH will bind. So this side Vint also will bind your BMP. BMP inhibitor. No, this is going to inhibit this BMP. Correct. So all these are there. DSH is also going. D-shield protein will bind such that they will inhibit your GSK, or else GSK will degrade this beta catenin. Correct. So much is there. Okay. So all these ligands and receptors definitely you should know. This ligands versus receptor. All these are very, very important. So all the examples you should know. Yes, everybody. Okay. See, one more question. Okay, similar type. Can you see this? So once you are exploring this pattern, definitely everybody can guess what these exam people are going to ask. They do not ask from somewhere else. Whatever they have already asked, they will do some kind of little bit of in-depth moving over the concept. They don't take a different concept, but the same concept, the level, the depth it may change. So see, can you see the difference between this question and this question? Yes, same year almost. Okay, so you have to follow the yearly trend also. No? So see, this is a CSIR December 17 question, and this is going to be a GATE 17 question. Okay, yes, so whatever it is asked in the GATE, so that was later asked in our CSIR. That is the meaning, because GATE occurs usually in February. Okay, so this was asked in December. So you have to be careful with this GATE paper if at all it is coming ahead. Okay, anyhow, coming back here, hedgehog, fork, hawks, vint, notch. Okay, right. So which is going to be the correct answer? Come on, yes, Moon, Mithila, Himanshi, Sayanti, Bhatt, Rumi, Gaurav. Very good, everybody in this class. Come on, guys, you all rock like anything. So what is this hedgehog? Hedgehog. You have heard about sonic hedgehog. If this is mutated, it is leading to a condition called cyclopia. So what do you mean by cyclopia? See, between the eyes we have a gap, right? So here the eyes must not be expressed. Then only you will get a bilateral eyes. If this is mutated, that's all. It will lead to the condition of a single eye, that is called as cyclopia. Got it? Okay. Next is Hox protein. Yes, absolutely. Yeah, one eye will be there in the center. Yes, correct. So next is going to be the Hox protein. Absolutely correct. Single eye will be in the center. So that is what. Okay. Hox protein. So Hox protein, it is what it is responsible. Hox genes are responsible for the limb development. Okay. So Hox is for the limb development. And then, so if it is going to be frizzled, frizzled is involved in the Wnt signaling. Wnt is the frizzled. And the notch. A notch is going to involved in the C. elegans, GLP. So delta notch, APX1, I think in our regular plus classes you could have studied this C. elegans development. There I taught you about this MOM1, MOM2, MOM5, ALP1, DLX1, GLP1, right? So all these are the interaction or the signaling. This GLP1, it is going to interact based upon the notch signaling. Okay, notch delta interaction is only taking place in the C. elegans. Okay, you remember about in the C. elegans, lot of questions used to come early, like this P1 and AB, which is called as a founder cell. P1 is called a founder cell, or AB is called a founder cell? Which is called as a founder cell, everybody in this class? It is P1 or AB? So which is going to be the founder cell? Come on, guys. Founder cells. Is it P1? No. P1 is a germ cell. The name only they have misled. AB is only the founder cell. Okay. So AB is actually somatic. Yeah, but they have named them as a founder. But always this tricks us because we think in our mind, we always remember that founder is like a stem cell. No, here founder is going to be the somatic cell. Okay, founder is the somatic cell. Only P1 it is the germ cell. Okay, right. So this P1 it is going to divide. Okay, so first there is going to be a zygote. Okay, so then the zygote will divide to form P1 and AB. Okay, right. So this P1 it is going to divide to form again one founder cell, one stem cell and one founder cell. Okay, right. So this one will divide to form AB anterior, AB posterior. So this will divide to form P3 and C. This will divide to form E and MS. Okay, right. So this will divide to form P4 and D. Okay, right. So this P1, P2, P3 and P4, they are only going to be acting as a germ cell. Okay, so all the others, this is going to form your ABA left. This is forming your ABA right. This will form your ABP left. This will form this ABP right. Okay, right. So these and all they are going to form the founder cells. So what are the founder cells? They are the somatic cells. So now one fellow is going to contain the P granules. Where this P granules will be present, name itself suggests. P granules it is with the germ cell. So it is only going to contain the factors like your skin 1, pol 1 and then pi 1. Okay, skin 1, pol 1 and pi 1 they are the R and P. Ribonucleoprotein. Yeah. So these are all going to contain this ribonucleoprotein. It is only going to make too much of signals. Okay. And that is only with that only it is having all the ability to divide and to make the pharynx. If at all this SKN1 is absent. Okay. If this SKN1 is absent, what will happen? If SKN1 is absent, what will happen? Yes, SKN1 is absent. So, there is no pharynx. Okay, there will be no pharynx. Right. That is a very important feature of your SKN1. Okay, right. Absolutely. This pol 1 it is with reference to your MS. Okay, pol 1 is with reference to your MS. It affects the mesenchymes. Okay, pi 1 it is for the germ cells. Okay, pi 1 it is for the germ cells. So skin 1 it is for your pharynx, pol 1 it is for your MS and pi 1 it is for the germ cells. These are all small points, but if you take everything together that will be a major issue. So now coming back to specification, I was telling you about this germ cell and founder cell. Always the germ cells, they have an important specification called as autonomous. It is all autonomous. What do you mean by autonomous specification? Something I am going to do it on my own. It is called as autonomous. You could have heard of these autonomous colleges. They conduct their own examination. They could give their own valuation to the students. That is what is autonomous. What is conditional? It is like a university or it is like an affiliated college. So the university, they don't do the things like autonomous, but they are dependent. Somebody is going to set the question paper. Exactly. If at all you are going to take an affiliated college, there our question papers will be set by the university given person. Okay, so that is what is going to be the affiliated or conditional. So somebody is giving the condition to you. That is the condition. It all depends upon this environment. Right? So now you got the difference between the conditional specification and autonomous specification. Conditional specification is going to be regulative. Okay, it is regulated by his environment, but autonomous, it is going to be self, it is mosaic. Okay, it is going to be mosaic. Yes, everybody. So this is clear. One more example we are going to take. See this question, it is for June 16. So many times the similar concept questions have come. Which one of the following combination is a correct pairing of ligands with the receptor? So which one of the following is the correct combination of a ligand with the receptor? FGF, hedgehog, Wnt, patched, frizzle, RTK. Simple, no? Huh? That's all. Very good, everybody. Come on, guys. Yes. Hedgehog, what did we see? Hedgehog is patched. Wnt is frizzled. FGF is receptor. Yes? Oh my god. Did I make wrong? Oh, sorry. Yes. Absolutely. Correct only, no? Yeah. So the correct option is going to be A. Correct. FGF is C. 1 is C. So by that only these two is eliminated. Right. And hedgehog is going to be patched. Just now we saw hedgehog is going to be patched. Wnt and frizzled. Wnt and frizzled. Very good, everybody. Yes, Nupur, Moon, Mithila, Sayanti, Bhatt, Gaurav, Moon. Very good, everybody. All are right. Okay. Good, everyone. So FGF, it is going to be tyrosine receptor kinase, RTK. Hedgehog patch, Wnt frizzle, delta notch. Delta is notch signal. Delta and notch signals, they are important. Got the logic now? Yes? Okay, so all the things put together is going to make a very big effort. Okay, so coming to the next concept, we are entering into 5B. Okay, so 5A is, that's all. Almost we have done with 5A. Okay, everybody. So shall we make up a move towards 5B? Right? Okay. So see this. In 5B, usually questions will come from fertilization. Okay. So as far as fertilization is considered, there are two fertilization. One, it is going to be the external fertilization, and other is going to be this internal fertilization. So who do the external fertilization? Who do the external fertilization? Sea urchin. Yes, sea urchin. It is doing this external fertilization. Okay. So who will do this internal fertilization? Mammals. The good example that we know is going to be mammals. Mammals do have the internal fertilization. Yes, everybody. Absolutely. Yes, Moon, Sayanti, Gaurav, Anantara, Nupur. Very good. Yes, Moon, Sayanti, Gaurav. Fantastic. So, who will use this vitelline envelope? Yes, Mithila. Vitelline envelope. Sea urchin or mammal? Who uses vitelline envelope? Vitelline envelope. Who uses? Vitelline envelope. Yes, it is going to be the sea urchin. Vitelline envelope is with the invertebrate. So it is going to be the sea urchin. So mammals, what do you use? We have the Zona Pellucida. Okay, right. So under the Zona Pellucida, you have Zona Pellucida 1, Zona Pellucida 2, Zona Pellucida 3. The Zona Pellucida, it is present in the egg. It is going to interact with the sperm. Okay, right. In the sperm, what do they contain? This is like a substrate. Okay, Zona Pellucida ZP3, it is going to act like a substrate. So the sperm is going to contain an enzyme. Okay, so this enzyme is called as this galtase. So this galtase is only going to bind with the ZP3. So the ZP3, it is going to be your glycoprotein. Okay, so this glycoprotein, whenever it is going to interact with this galtase enzyme from the sperm, then only the first binding will take place. Understood this concept first? Yes, everybody? Is this concept clear? Should I tell you one more time how this binding occurs? So one more final time I'll tell you, then you can take this question easily. I am telling how this binding occurs. Okay, so in this Zona Pellucida of mammals, okay, so you are going to have 3 fellows, ZP1, ZP2, ZP3. This ZP1, it is called as a linker, not much importance. ZP2, it is for rebinding. You call them as the binding with the acrosomal reacted sperm. What do you call them as? Acrosomal reacted sperm. That is what is going to be this binding. And what about ZP3? ZP3, it contains this glycoprotein. It is going to bind this galtase of the sperm. Okay, so that is why it is exactly fitting, like an enzyme substrate reaction, it is taking place. Clear? Right? Okay. So now what they are doing, let us see in this question, you will understand more depth from this aspect. So during the fertilization in mammals, the sperm egg interaction, it is mediated by Zona Pellucida. It is a membrane protein. Okay, so the receptors, it will be present in the sperm membrane. Okay, right. So the ZP3, it was identified as a very important protein for the sperm egg interaction. We also know that. So they are conducting an experiment. What is the experiment? It is called as competitive inhibition assay. So what experiment they are performing, like how we do it in the ELISA, just a minute, they are doing this competitive inhibition assay. So what they do in this competitive inhibition assay, so what they do is that the sperm is going to get saturated with this ZP3 or its modified forms. Okay, right. So so they are going to study the sperm egg interaction. Okay, so which of the following will not at all inhibit the sperm egg interaction, they are asking. Okay, think and answer. You are saturating the sperm with ZP3. You deglycosylate the ZP3 protein and use it. You phosphorylate them and use it. You dephosphorylate them and use it, which will not inhibit the sperm egg interaction. One and only if you listen carefully, you can answer this question. Sayanti, correct. Good everyone. Good try. Okay, first I will tell you one point. Then we will come back to this. Okay. So what do you mean by competition? Sure, but what do you mean by this competition? There is going to be one sperm. To this sperm, you are adding this egg number 1. Okay. If these two are bound, okay, now you are adding this egg 2. Can this sperm now bind the new egg? Can this sperm is already bound with this egg 1. Can it bind with the egg 2? Is there going to be any kind of binding? No binding, isn't it? So they do not bind with my egg 2. Okay, so it is leading to competitive inhibition. Okay, if it is all normal, it will lead to competitive inhibition, that is no binding. In the question they are asking the condition when there is going to be no competitive inhibition. That means to this sperm, if at all you are adding deglycosylated ZP3 containing egg, will the sperm bind or not? Will the sperm be able to bind or not to this egg number 1? Will it be bound? No, no ZP3, no binding. So So there is a free sperm. Whenever there is going to be a free sperm, now you are going to add this egg too. This is going to bind. If it is binding, there is no competitive inhibition. That is what they ask. So the correct answer is deglycosylated egg. It will only result in no competitive binding. How many of you understood this question? If you are not understanding, I will tell you one more time. See this? Yes, Tripadiyam. Good morning. Which of the following experiments will not inhibit? If at all, I'll tell you. If at all you are saturating the sperm with ZP3. If at all you are saturating the sperm with ZP3. Okay, this egg 1 is containing ZP3. Okay, so this egg 1 is containing ZP3. It could have binded to the sperm. So when you add the egg 2, there is competitive inhibition. Yes or no? Do you understand the first point now? You have to understand that there are two eggs. First egg and then second egg. So second egg condition only they are asking now. What is happening to the second egg only they are asking. Okay. So if at all it is already bound, if you have this ZP3, you add the sperm, it will be already bound. So there is no sperm available for the egg 2 to bind. So there is competitive inhibition. So they are saying it is not inhibited. So I am eliminating this option. Okay, let me come to this point number 3. You phosphorylate this ZP3. What is important for binding? Phosphate is important or glycoprotein is important? Which is important? Which is important? Is it phosphorylation? No, only this glycoprotein, because I told you this glycoprotein is only going to bind with the galtase. Galtase, it is in the sperm. Glycoprotein is present in the egg vitelline membrane. So only this glycoprotein is only important for binding. I don't mind if it is phosphorylated, it is dephosphorylated. It is no way going to connect me with the experiment, because my binding site is only glycoprotein, because the sperm is only going to contain the galtase. It is not containing phosphatase. Got the point? If at all the sperm is going to contain the phosphatase, at that time this phosphorylation maybe could have played a role, but fortunately or unfortunately, this enzyme in the sperm, it is only going to be this galtase. Since because it is going to be the galtase will look only for this glycoprotein or glycosylation. If glycosylation is there, it will bind. If it is bound, it is competitive inhibition. If it is not bound, it is non-competitive inhibition. Got it, guys? So one more time, shall we just see one more example? Okay, just give me a couple of seconds. Right. So see, this is going to be the sperm 1. Okay, right. So now I am adding it to the ZP3. Okay. So this ZP3, it is going to be dephosphorylated. I am talking about sperm 1. Can it bind? Can it bind? Think and answer. I am saying that it can bind. Yes? How many of you got this point? How many of you understand that definitely it will bind? Yes, it is going to bind, because if you dephosphorate also, my glycoprotein is there still. Okay, so my glycoprotein is active. So it is going to bind. Okay, so now I am adding this egg 2. With this egg 2, will this sperm 1 bind? I am saying it is not binding. How many of you say it is right? True or false? This statement is true or false? This is a true statement. Why? Because already the sperm 1 is bound to this egg 1, no? So already it is bound to this egg 1. So none will be available for egg 2. Got the logic? See, that is why they call it as a competitive experiment. See, this is going to be the sperm. Okay. So this is going to be this egg 1. Okay. So if these two is already bound. Okay. So one more egg is there. So this will be free only, no? So the sperm is not binding this fellow. Okay. But you imagine that this sperm, it is not binding this egg 1. Okay. It is free. Okay. So now if you add this egg 2, it can bind. That is what the competition between this egg 1 versus egg 2. Now did you understand where is the competition? See, this is similar to that of this story. What is that? We could have studied this interaction in ecology. We could have studied. So there is a tiger. Okay. If the tiger eats the rabbit, the deer will escape. Correct. If the tiger is not eating this rabbit, then this fellow will fall. Isn't it? Like that, if the sperm 1 is binding with your egg 1, egg 2 cannot bind. Okay, because it is already bound. But if the sperm 1 is not binding with this egg 1, egg 2 can bind. That is all. That is what is the competitive thing. So now everybody understood what is this competitive formation? Okay, fantastic guys. Okay, fine, right. Okay, see, identify the correct statement from the following. Yes, everybody. The removal of threonine, serine linked carbohydrate groups from ZP3 helps to bind the sperm. Deletion of surface protein from the sperm can inhibit or eliminate the sperm zona binding. ZP3, it is the specific glycoprotein to which the sperm is binding. Both B and C, which could be the correct statement. This can be A, this is B, this is C, this is D. Yes? Everybody else? Clear? Absolutely. So both your B and C with option D is going to be correct. Yes. So if you, this is not related with your serine threonine and all. It is only your glycoprotein. Okay. And then if you delete the surface protein, okay, the sperm, it is going to be inhibited because it is only going to contain this galtase. So galtase is also required. Glycoprotein is also required. So both of them it should be there. Then only you will be able to bind. Got it? Yes. Chromosomal vesicle. It is derived from which of the following? These are all our unit quiz. Unacademy unit quiz. Okay. Chromosomal vesicle is derived from which of the following? Very direct. Golgi apparatus. Right? Yes. So chromosome, it is going to be derived from this Golgi apparatus. Okay. Fine. So this is another important molecule, another important aspect. This force, is the question visible? Should I zoom it little bit? Wait a minute. I'll zoom it for you. I think it's very small. Okay. Okay. So identify. Identify the correct statement from the following. The force for the sperm for propulsion, it is provided by dynein. Histone H1, it is only stabilizing the flagellar microtubules. If dynein is lost, the sperm can be motile. Even if this dynein is lost, the sperm can be motile. Dynein, it hydrolyzes the molecules of ATP. So which one of the following is going to be correct? Everybody in this class. Yes, all. Yes, everybody. Come on, guys. Very good. See, dianen is very, very important, isn't it? Yeah. But it is going to be 1, 2 and 4. So option A is going to be correct. 1, 2 and 4 with option A it is going to be correct. See, we all know that dianen is ATP hydrolyzer. Okay, so it is helpful in movement. So ATP hydrolysis will take place. Yeah, so 1, 2 and 4. A is the correct answer. And this propulsion is provided by dianen. Definitely these two I know. But for this point B only I wanted to take you this question. This histone H1, it is a linker histone, no? That is very, very important to stabilize the flagellar microtubules. If it is lost, it is going to make immotile sperms. Okay, so if at all there is a problem with this, it will lead to some bronchial infection also and insterility also. It is a very, very important point to be noted. In Gilbert, it is very directly given. This is a question from Gilbert only. I think it is not a PYQ. These are all my self-prepared questions. So you could not have accessed this so far. Yes? Okay, but it is a very important point to be noted. Got it, everybody? Okay, guys. So almost it's time up. So if you find something wrong, just tell it. The things are there in the description box. You can definitely make it out. And please do remember that this offer is going to end today. So it is ending by today. So if at all you or your friends are looking out for preparation, please keep them motivated. Okay, so this time let's see how much is the turnout. And today I have one more session by 12 p.m. Yes, Gaurav, you can definitely take off this in the special class. Okay, so in the special class only you will be getting this PDF. If you want this, you can definitely reach us. Okay, alright. So 12 p.m. and 5 p.m. We are going to have continuous sessions. So 10th unit as well as, yes, but so 10th unit as well as, yeah, definitely we'll bring one more. So already one non-PYQ series have just ended. Okay, so today I'm planning to take this mitochondrial mitochondrial replication. I am planning for one special class and one more on this overall revision. I see genetics you want. Okay, we'll plan to take it out. Alright guys, so that's all for now. I'll meet you back by 12 p.m. Don't go away. All the very best. Keep learning, keep preparing. I'll catch you with more.